Assalamualaikum and hi everyone. So this is a video for chapter 2, Thermochemistry. In this video, we're going to focus on subtopic 2.2 Calorimeter, and at the end of this lesson, you should be able to first define heat capacity and then specific heat capacity. And also we will do some calculation. Now we're going to start first with heat capacity. So, heat capacity. If you look here, the symbol for heat capacity is capital C. You need to make sure that you see this because later when we talk about specific heat capacity, the symbol is still the alphabet C, but we use small c. So, capital C is for heat capacity. Okay. So heat capacity is the amount of heat required to raise the temperature of a substance by 1 degree Celsius or 1 Kelvin. Okay, as you can see here, heat is Q. So after this, when you see the symbol Q, it's either we put as Q or small q or capital Q. Both are talking about heat. Okay. Both are talking about the enthalpy. Okay, now, next, the unit for our heat capacity is joule per degree Celsius and also joule per Kelvin. So if you look here, we have the unit joule, meaning because heat is an energy, is a type of energy. So that's why energy, the unit for energy is joule. The equation for heat capacity is C, capital C, equals to Q over delta T. So, the delta T over here is the difference in temperature, okay, for that certain reaction. And lastly, if you want to relate the heat capacity with the specific heat capacity, we will relate it by its mass. So heat capacity from the equation, okay, is C, heat capacity, equals to mass of the substance times its specific heat capacity. So this is what I meant by you need to make sure that you use the correct alphabet. Okay, the small c here is for specific heat capacity. Okay, and then from here, the equation that we will use throughout the calculation is Q equals to C delta T. So this is the equation that we will use later on when we want to find what is the value of heat release or heat absorbed during the reaction. Now, let's take a look on what is specific heat capacity. So, specific heat capacity, so if you look here, the symbol is small c, is an amount of heat, okay, amount of heat required to raise the temperature of 1 gram of the substance by 1 degree Celsius or 1 Kelvin. The difference between heat capacity and specific heat capacity is mass. Okay, for both heat capacity, we want to know what is the amount of energy needed, amount of heat needed to increase the temperature by 1 degree Celsius or 1 Kelvin. But when we talk about specific, we want to know what is the amount of energy needed for us to increase the temperature of 1 gram of some substance. Okay, next, the unit. So, unit for specific heat capacity, since we have mass just now, so the unit will be joule per gram per degree Celsius or joule per gram per Kelvin. So, this depends on the unit of temperature that's given to you in the question. Okay, next, the specific heat capacity. So this is the equation to find the specific heat capacity. C equals to Q, our heat, the amount of heat that we have, over mass times its change in temperature. Okay, so we can conclude that to find heat, the equation that we will use is Q equals to mc delta T. Okay, so now, before this, the equation that we have is Q equals to C, heat capacity, delta T. Okay, when are we going to use this equation? When are we going to use this equation? Depends on what's the information given to you. So, usually, if the question gives you mass, we will use this one, Q equals to mc delta T. But if the question only gives you the information on the heat capacity alone, so we will use Q equals to C delta T. So that's why it is very important once you get the question to analyze and write back what is the information that is given. Okay. So heat is transferred between a system and its surrounding as a result of a temperature change. So this we have discussed earlier. Okay, it's everything about heat. Okay, heat, it will flow from hot body object to those colder. It will flow from higher temperature to lower temperature. And again, I said it will always be like that. Okay, flow from higher temperature to lower temperature. So heat release is equal to the heat absorbed, because why do we say that heat release equals to heat absorbed? Okay, we are following one law. The law that we follow over here is what we call as the first law of thermodynamics. Okay, so what does this first law of thermodynamics state? So it's basically our law of conservation energy, where we said that the energy of the system, it cannot be created and it cannot be destroyed. The energy can only be moved around or changed into another form of energy. Okay, so basically that is your first law of thermodynamics. Okay, so that's why by using that law, we said that the heat released is equal to the heat absorbed. So if the reaction, so let's say the system release, okay, system. Okay, if the reaction release heat, so something else must absorb the heat release to conserve the total energy. Okay, so that's why this will be the equation that we will use throughout the calculation later. Okay, this is the law that we're going to stick on, where the heat release equals to heat absorbed. Okay, so by right, supposedly, if you refer to your lecture note, okay, if we say about this, since we are conserving the energy, it's supposed to be Q absorbed plus Q release equals to 0. 0 here means the energy is conserved, it is not destroyed, and no new energy is formed. Okay, so by right, if I rearrange this equation, we will get as Q absorbed equals to negative Q release. Okay, this is the equation that it should be. But since I don't want you to get confused when calculating later, calculating the questions later, so I will remove this negative sign here. But please bear in mind, when we talk about heat release, release of heat, meaning we will have negative sign. Okay, I will guide you one by one on how to answer the question and when to put the negative sign. Okay? Now, let's take a look at some example questions on heat capacity and specific heat capacity. So, this is example 1. A 446 gram sample of water is heated from 8.5 degrees Celsius to 74.6 degrees Celsius. So calculate the amount of heat absorbed in kilojoules by water. Okay, before I proceed on solving this question, I just want to tell you that the type of question that you will have for calorimeter, we have two types of question. One, this is a simple heat transfer question where we only have heat transfer and it does not involve any chemical reaction. We don't have neutralization, we don't have combustion. Okay, just a simple heat transfer from one body to another one. Okay, the next type of question, it involves a chemical reaction. Okay, and this chemical reaction will be done inside a system or inside a device, what we call as calorimeter. We have two types of calorimeter. Okay, that one will be discussed further in next video. But for this one, it's just a simple heat transfer question. Okay, so back to question number 1. The information that we have here, the question gave you first the mass of water. So we have mass of water 446 gram and you are given temperature 8.5 degrees Celsius to 74.6 degrees Celsius. Okay, this is our heat change. So the question asks, calculate the amount of heat absorbed. Okay, amount of heat absorbed in kilojoules by water. Okay, so let's rewrite the information. So this is the mass of water that we have. Okay, mass of water, and then we have here initial temperature, and then this is the final temperature. To find out why it is important for you to know the temperature here, because we want to find the change in temperature. Okay, and then the question asks to find what is the amount of heat absorbed. So the question asks for Q. So since the information that we have is mass and also delta T, the equation that we will use is Q equals to mass of water, specific heat capacity of water, and then delta T, because we want to find heat absorbed by water. Okay, so now let's take a look on how to solve this question. So this is the question that we have just now and all the information that we have taken out. Okay, so like I mentioned before, the principle that we will hold for any thermochemistry question is Q release equals to Q absorb. Okay, and what you need to understand over here is the amount of heat release will equal to the amount of heat absorbed. So amount is the same. The only difference is either the action, heat being released or heat being absorbed. Okay, now and like I mentioned before, my method of calculating is slightly different from the one that you can find in your lecture note and also your maybe some reference book, where usually they will put negative sign over here. Negative Q release equals to Q absorb. Okay, but for me, I will not put negative sign over here to ease your calculation, to make your calculation easier. But I will guide you step by step on how I do it. Okay? Okay, now. So let's take a look back at the question. How do we determine either for that reaction heat is being released or heat is being absorbed? Okay, usually you will have both information. One thing is releasing heat and the other one is absorbing heat. So if you have those two information, okay, you will use Q release equals to Q absorb. How do we determine? How do we know that thing, the reaction will release heat or will it absorb heat? The way of knowing is by checking the final temperature. Analyze the final temperature. So our final temperature here is 74.6. Compare with the initial temperature. What do you see? You see an increase in temperature. So increase in temperature. When you have an increase in temperature, this means that the reaction, what we have here is heat absorbed. So it will be vice versa. If the initial temperature is higher than the final temperature, this means that that particular system has lost its heat, meaning heat is released. So for this question, heat is absorbed. Okay, next, do we need to use this equation for this question? No, we don't have to use this equation. Why? Because in this question, you simply only have one thing, one system. The story is only about water and there's nothing else. Meaning we will only talk about the energy being absorbed by water only. So that's why we will simply use this equation. And next, since in the equation we will use delta T, so calculate separately for delta T. And for my method of calculation, your delta T will always be the bigger temperature minus the smaller temperature. It doesn't matter if it's initial or final. I will not use final minus initial. I will always use bigger temperature minus the smaller temperature. I will explain it later. So for this one, the delta T will be 74.6 minus 8.5. So the delta T that you will have here, the value is 61.1 degree Celsius. So once you have all the information here, so please make sure that you write down your equation as detailed as I did. So if Q absorb, who absorbed the heat? So for this question, Q absorbed by water. Since we are talking about water, so the mass must belong to water. The specific heat capacity must also belong to water, and the delta T, of course, it must be for the water. So the mass of water given is 446 gram, and you need to make sure that it is in grams. Why? Because the specific heat capacity of water. In this question, the specific heat capacity is not given. Why is it so? This is because the value of specific heat capacity is given to you in the list of constant. It is something constant. So the value for specific heat capacity of water is 4.18 joule per gram per degree Celsius. So this is the value. So if you look here, the unit used is joule, gram, and degree Celsius. So that's why the mass of the water, it must be in grams. So let me show you one example here with all the units. So mass of water in gram, specific heat capacity of water, which is given in your list of constant. If it's not given, memorize this value. This only value for water. So 4.18 joule per gram per degree Celsius. And then the delta T. So the delta T as well, make sure that the unit is the same. If given to you in Kelvin, So the temperature must also be in Kelvin. Okay, so it will be 66.1 degrees Celsius. Okay, so the unit will cancel out, and the final answer after you calculate using your calculator, you will get as 123,228.9, and the unit is in joule. Okay, but look back at the question. It asks to find the amount of energy, the amount of heat absorbed in kilojoules. So what you need to do? Divide by 1000. So you will get your answer as 123.23 kilojoule. Okay, so now let's move on to example 2. So, example 2. A lead pellet having a mass of 26.7 gram at 89.98 degrees Celsius was placed in a constant pressure calorimeter of negligible heat capacity containing 100 milliliter of water. The water temperature rose from 22.5 degrees Celsius to 23.17 degrees Celsius. Calculate the specific heat capacity of the lead pellet. And the question here already gives you the amount, the value of specific heat capacity of water. Okay, now let's analyze this question, and actually you can see that example 2 is slightly different from example 1. Okay, how does it difference? For example 1, we only have water, but here in example 2, we have lead pellet, and then at the same time there is information on water. Okay, so let's take out the information first. So this is for lead. Okay, so this is the mass of lead and then its initial temperature. Okay, so let me write that down. So this is mass for PB. Okay, and then this is T initial for PB. And then the next part, the information that's given to you, okay, the lead is placed in a constant pressure calorimeter of negligible capacity containing, here we have 100 ml of water. Okay, and then the temperature of the water temperature rose from 22.5 degrees Celsius to 23.17 degrees Celsius. Okay, so this will be the volume of water, and then this is the initial 22.5 is initial temperature of water, and the 23.17 is final temperature of water. And actually, besides final temperature of water, this is also the final temperature of the plumbum. Okay, why do I say it like that? Okay, so you need to imagine for the reaction. So inside a calorimeter, first, okay, you have a pellet, a plumbum pellet here, okay, of temperature 89.98 degrees Celsius, and then you have a water at initial temperature of 22.5 degrees Celsius. So what you do next is you put the lead into the water. Okay, you put it there, and then it will sit here. Okay, when it sits inside the water, what happens? It will achieve thermal equilibrium. So the temperature, the final temperature of the water will be the same as the final temperature of the lead pellet. Okay, it will be the same because you cannot separate. Oh, PB will have different temperature than water. But the thing is, they are inside the same system. Okay, so that's why the final temperature is the same. Okay, so the question here, calculate the specific heat capacity of the lead pellet. Okay, now, so let's move on to the calculation on how to find the specific heat capacity of the lead pellet. So this is our question just now and all the information that we have discussed earlier. Okay, so this one at the left hand side is for the lead pellet, and then on the right hand side is all the information on water. So this is the diagram on what's happening actually. So at first we have a plumber, okay, a lead pellet here with the initial temperature, and then it is put inside water that has 22.5 degrees Celsius temperature. So what happened after the two are mixed together? Okay, they will gain thermal equilibrium and they will have final temperature of 23.17 degrees Celsius. How do we know this value? It's from the measurement of the temperature of water. Okay, so that's why the final temperature of water of pellet here also will be 23.17 degrees Celsius. So now, to answer this question, since we have two different components, we need to know which one will absorb energy, which one will release energy. So this is a question where you need to use Q release equals to Q absorb. And the equation for Q, we have two different equations. Either we want to use Q equals to MC delta T, or Q equals to heat capacity delta T. Okay, so this depends on what information do we have. So for this question, we will use this one because both of our component here has mass. Okay, now, so let me remove this first. Okay, back to the information. So we need to analyze which one will release heat, which one will absorb heat. Okay, so look at the initial and final temperature for PB. So the final temperature here is lower than the initial temperature. So what does this mean? So this means that heat is released. Okay, because the final temperature of PB is lower. Okay, and for water, water is the one that absorb heat. So here, heat absorb. Okay, so like I said before, we will find the value of delta T outside. Okay, so for this one, the value of delta T, so like I mentioned before, it will always be the bigger value minus the smaller value. Okay, so 89.98 minus 23.17. So the delta T for lead is 66.81 degrees Celsius, and it is heat release. And then the delta T for water is 23.17, since that's the bigger or the higher temperature, minus 22.5. So you will get the change as 0.67 degrees Celsius. Okay, so to use Q equals to MC delta T, we need to have the mass of water that given to you is 100 ml volume. Okay, by using the density of water as 1 gram per ml, we can say that the mass of water is 100 gram. So once we have all the information, then we can put inside the equation. So like I said, the equation must be specific. So who released the heat? So Q released by PB. Okay, please make sure, please write down exactly like I did. And Q absorbed by water. Okay, then we put the information. So mass PB, specific heat capacity of PB, and delta T, So here is mass, water, specific heat capacity of water, and then delta T for water. Okay, so once you have this equation, so now you can very clearly see what information you should put in. So the mass of PB we already have, so 26.47. Okay, so specific heat capacity of PB that we want to find. Okay, and then the delta T for PB is 66.81. Okay, by writing down the equation very clearly like this, it will help you to avoid making mistake of putting the incorrect information. Okay, because here you have two different delta T and different temperature and also mass. So to avoid confusion, make sure clearly show everything. So the mass of water is 100 ml, specific heat capacity of water 4.18, and delta T for water is 0.67. Remember, the delta T is different because they have different initial temperature. Okay, so calculate everything, rearrange and calculate. You will get the specific heat capacity of pellet, of the lead pellet, to be as 0.158 joule per gram per degree Celsius. Now, example 3. A 1 gram sample of aluminium and 1 gram sample of iron are heated from 40 degrees Celsius to 100 degrees Celsius. So, which metal has absorbed a greater amount of heat? Okay, so for this question, we have two different metal. First, we have aluminium. The second one, okay, here we have iron. Okay, the mass of aluminium is given as 1 gram and the mass of iron also given as 1 gram. And then both metals are heated from 40 degrees Celsius to 100 degrees Celsius. So what do we understand over here? So this is mass aluminium, this is mass of iron, and both initial and final temperatures of the two metals are the same. So this is the initial temperature, this is the final temperature. So the question asks, which one, either aluminium or iron, has absorbed a larger amount of heat? Okay, maybe you will think, oh, isn't the temperature rise the same? It's delta T, if you calculate, it will be 60 degrees Celsius. But why is the amount of heat absorbed different? Okay, that is because of the capability of that specific metal to absorb heat. Either it can absorb heat faster or it can absorb heat lower. Okay. Okay, to explain further about this phenomena, izinkan saya menggunakan bahasa Melayu kerana lebih mudah untuk saya terangkan. Okay, contoh adalah kuali dekat dapur. Okay, kuali yang awak masak untuk goreng ikan tu kan. So, ada dua kuali. Satu kuali yang diperbuat daripada karbon, satu lagi kuali yang diperbuat daripada maybe granite. Okay, two different materials. And then awak masukkan minyak ke dalam kedua-dua kuali. Lepas tu awak goreng ikan. Okay, so untuk tentukan siapa yang ada specific heat capacity yang lagi besar is kuali yang minyak dia jadi lagi panas dengan lebih cepat. So mana yang panas lagi cepat tu maksudnya dia ada capability
dia ada kebolehan untuk absorb heat lagi banyak dan lagi cepat compared to the other one. Okay, so that's the explanation. Now I'm going to revert back to my mode of language, which is English. Now, let's go back to the question. Okay, so the question here, let me take out all the information that we have. So we have here mass of aluminium, 1 gram, and then mass of iron, also 1 gram, and both temperatures are the same, so I just put as delta T over here. So the bigger temperature, 100, minus the smaller temperature, which is 60 degrees Celsius. But you still need to identify either it is heat absorbed or heat release. So since here, the final temperature is higher than the initial temperature, so it shows that this reaction is heat absorbed. Spell absorb, A-B-S-O-R-B-E-D, S-O-R-B-E-D. Okay, thank you. So, heat absorb. Okay, why do you need to determine it's heat absorb or heat release? Because you want to write down on the equation. Okay, so the equation will be Q absorb by aluminium, and then Q absorb by iron. Okay, so the equation, you will do separate calculation. So for aluminium, you must have mass of aluminium, specific heat capacity of aluminium, and delta T. For iron, mass of iron, specific heat capacity of iron, and also the delta T. So substitute all the information, all the value that you have. So mass of aluminium is 1, specific heat capacity of aluminium given here is 0.9, okay, and then delta T is 60. So you will get the heat absorbed by aluminium as 54 joule. And then do the same calculation for iron. So mass of iron is 1 gram. Specific heat capacity given here 0.444 joule per gram per degree Celsius, and the delta T is the same, 60. And you will get the heat absorbed by iron as 26.64 joule. Okay, so if you compare these two values, 54 and 26.64 joule, we can make a conclusion that aluminium will absorb more energy than iron. Okay, just by looking and compare the heat absorbed by the two metals. Okay, so now let's move on to the final question.
The last example, example 4. In a calorimetry experiment using a polystyrene cup, a 59.7 gram piece of metal that had been submerged in boiling water was quickly transferred into 60 ml of water, which is initially at 22 degrees Celsius. So the final temperature is 28.5 degrees Celsius. So determine the specific heat capacity of the metal. Okay, now. So in this question, okay, let's take out all the information that we have. The first one given to you is 59.7 gram piece of metal, so mass of metal, okay, had been submerged in boiling water. So this is a piece of information. Why? Because what is the temperature of a boiling water? So it should be 100 degrees Celsius, and this will be the initial temperature of the metal. So here is your mass of metal. Okay, next, what information we have? Is quickly transferred into 60 ml of water. Okay, 60 ml of water, which initially at 22 degrees Celsius. Okay, so the final temperature is 28.5 degrees Celsius. So determine the specific heat capacity of metal. So the question asks for specific heat capacity of the metal. Okay, more information. So this is volume of water and 22 degrees Celsius is the initial temperature of water, and this is also the final temperature for both of our metal and also the water. Okay, so now how are we going to solve this question? So let's take a look.
Okay, so this is our question and all the informations and what's happening actually. So this is the first part when I said that a metal is submerged into a polystyrene cup that contains boiling water, and then the metal is transferred into another cup that has water of 22 degrees Celsius, and the final temperature of the metal and the water is 28.5 degrees Celsius. So we will write down the final temperature. Okay, I already wrote down here the final temperature. Now, let's find the delta T first. Okay, so for the metal, 100 minus 28.5. So the delta T will be 71.5 degrees Celsius. And for the water, I put as 60 gram because given to you is 60 ml. So density of water 1 gram per ml. So the mass of water will be 60 gram. And the delta T for water, 28.5 minus 22. So it will always be the bigger temperature minus the lower temperature. Okay, so here the delta T will be 6.5 degrees Celsius. Now, determine which one absorb heat and which one release heat. Okay, by looking and comparing the initial and the final temperature. So for the metal, the final temperature drops from the initial temperature. So meaning here we have heat release, so Q release. And then for the water, the initial temperature is lower than the final temperature. Okay, the final temperature shows that there is some energy absorbed. So this will be Q absorbed. Okay, after that, we're going to write down our equation. So Q release by whom? Q release by metal equals to Q absorbed by water. Okay, and analyze what information do we have here. So the question asks for specific heat capacity of metal. So C for metal, and we do have the specific heat capacity of water. Even though it is not given, we do know that the value is 4.18 times 10 joule per gram per degree Celsius. So that's a fixed value, meaning the equation for heat that we're going to use is Q equals to MC delta T. So Q metal, specific heat capacity of metal, and then its delta T equals to Q water. Sorry, it's not Q, mass. Okay, pardon me. Okay, mass of water, specific heat capacity of water, and delta T. Substitute all the informations that we have. So mass of metal is 59.7 grams, and then specific heat capacity of metal, the one that we want to find, and the change in temperature for the metal is 71.5. And then mass of water 60 gram, specific heat capacity of water 4.18, and delta T for water 6.5 degree Celsius. Okay, so find what is the specific heat capacity of metal. So you will get the answer here as 0.382 joule per gram per degree Celsius. Okay, we are done. So for this type of question, the one that we did so far, from example 1 to example 4, like I mentioned before, this is just a simple question where we have simple heat transfer. Okay, from a higher temperature to a lower temperature. Okay, and this does not involve yet our calorimeter and does not involve any chemical reaction such as neutralization and combustion. For that, we will discuss on the next video. We're going to do a few more calculations on calorimeter in the next video. So for now, thank you.